So today we're going to look at this question: how do you add or subtract algebraic fractions? So that's fractions with algebra in them. We're starting off quite slow, and we're just looking at adding normal fractions such as a third plus a quarter, because what we're going to find is that the same principles apply to when we're adding algebraic fractions. So what we would do here is, hopefully you know how to do this, we would change both fractions into fractions over 12. The 1/3, which was here, would become 4 over 12. That 1/4 would become 3 over 12. How did we pick 12? Well, we simply multiplied these two numbers together. We got a lowest common multiple of these numbers, which in terms of fractions is called your lowest common denominator. And we added those fractions together to get 7 over 12. So these are the steps we took. In the answer, we kept the denominators the same, and we just added the numerators. Okay. So just as an aside, why does that work, converting fractions? What you do to the top, you do to the bottom. Why does that lead to fractions that are equal? Well, let's look at 1/3 and 2/6. We've multiplied the 1 by 2. We've multiplied the 3 by 2. The number of slices we've had is doubled, but the number of slices that the cake is cut up into is doubled as well. So we end up with twice as many slices, but each slice is half as big. That's why we can convert fractions in this way. What we do to the top, we do to the bottom. We double the number of slices, just at the same time as we half the size of each slice. So that's the maths behind converting fractions. The same goes no matter what you do to the top and the bottom. You can multiply that by 3 and multiply this by 3. The number of slices you have triples. The size of each slice is divided by 3, as we can see. That was our 1 slice before, and now we have 3 slices. Each one is 1/3 of the size of what it was before, so we have the exact same amount of cake. And obviously that goes for no matter what it is you do to the top and the bottom. As long as you do the same thing, you end up with fractions that are equivalent. So just to go through the process of adding normal fractions, adding 5 over 7 plus 3 over 5. What we're going to do first is we're going to find a new lowest common denominator, which is going to be 35. And the way we get that is just by multiplying these two numbers together. We multiply these numbers together, we get a number that's a lowest common multiple of both of these numbers, and that can be the new lowest common denominator of our fractions. Again, I'm going through this just to show that algebraic fractions are exactly the same, and we can get to quite complicated algebraic fractions just by following these basic principles. So find the lowest common denominator by multiplying those two denominators together. 7 times 5, that's going to make 35. We're going to end up with 5 over 7 equaling 25 over 35, just by multiplying both of those by 5. We're going to end up with 3 over 5 becoming 21 over 35. And now, instead of 5 over 7 plus 3 over 5, we've got two fractions that are equivalent. And in the answer, we are going to keep the same denominator all the way through. That's important, the same denominator all the way through, and simply add the numerators, and our answer is 46 over 35. We could change that into a mixed number, but it's not necessary for this task that we're doing. So all we've got now is we've got a over 7 plus b over 5, but the exact same principle applies. Okay, our lowest common denominator is going to be these two numbers multiplied together, 35. We're changing a over 7 into a fraction over 35. Okay, so we're multiplying both of those by 5. A over 7 turns into 5a over 35. Then we're looking at b over 5. Remember, our lowest common denominator is going to be 35. So we need to look at that fraction, b over 5. We need to multiply both sides by 7. And b over 5 is equal to 7b over 35. So that's the next step. We've got 5a over 35 plus 7b over 35. The answer is going to have the same denominator, and all we're going to do is add the two numerators. We would simplify them, but we can't actually simplify these any further. So that is our final answer, 5a plus 7b over 35. Okay. I'm going to give you a chance to have a go at this one yourself. So just press pause and have a go at this. Okay, as you can see, the two denominators are a and b. Well, what did we do when this was 5 and this was 7? We multiplied the two together to get our new lowest common denominator. So now our new common denominator is going to be ab. Okay, just multiplied these two together. So we need to change both of these fractions into fractions over a, b. Okay, so 5 over a. What do we need to do to a to get into our new lowest common denominator, which is ab? Well, you times it by b. Okay, a times b makes ab. What I do to the top, I've got to do to the bottom. So I've got 5 times b becomes 5b. And 5 over a becomes 5b over ab. Okay, and what I do next is I look at the 3b, okay, and I apply the same principles there. Okay, I've got to change that 3b into fractions with the same denominator. Okay, so what do I need to do to b to make it into ab? Well, I've got to times it by a, so I've got to do the same to the top. I multiply both of those by a, and I get 3a over ab. Okay, so now I've got fractions where the denominators are the same. My answer is going to have the same denominator. It's going to become 5b plus 3a over ab. So that's the answer to this fraction question here. 5b plus 3a over ab. Just going back a step there, what you'll see is this 5 over a, I've multiplied both of those, both the numerator and the denominator, by b to get 5b over ab. What I've done here is I've taken the 3b, 3 over b, and I've multiplied both of those by a to get 3a over ab. Okay, here's a question, a problem question where we might have to apply this kind of adding of fractions. You need to design a fuel tank such that half a tank of fuel added to a third of a tank of fuel adds up to 70 liters. What volume should the fuel tank be? Well, I'm starting off with x over 2. Okay, I'm letting the volume of the fuel tank equal x liters. So if I take half of a fuel tank, how do I half something? I divide it by 2. And if I add that to a third of a fuel tank, how do I find a third of something? I divide it by 3. If I take a half plus a third of that full tank, and if I add the half plus the third, I need to get 70 liters. Just have a go at trying to find out what the value of x is going to be. Okay, so what I need to do is I've got a fraction over 2, I've got a fraction over 3. I want to get the same denominator, so I can add those fractions together, and that's going to be 2 times 3, which is 6. I need to make them both into fractions over 6. So that's x over 2 becomes 3x over 6. I'm just multiplying those by 2. X over 3 becomes 2x over 6. I'm just multiplying the top and the bottom both by 2. Okay, then I'm adding them together. And when they add together, they should equal 70. Okay, so what does 3x over 6 plus 2x over 6 make? Well, in my answer, I'm going to keep the same denominator and just add the numerators together. So they're going to become 5x over 6. 5x over 6 equals 70. So how do I find out what 5x is? I don't like that denominator there because it makes things a little bit more confusing. So what I'm going to do is I'm going to multiply this side by 6, and I'm going to multiply that side by 6. And that multiplication by 6 is going to reverse the divide by 6. It's going to cancel the divide by 6. So I'm going to be left with 5x equals 420. Now I need to find out what x is. At the moment, x is being multiplied by 5. I need to cancel that multiplication by 5. So I need to divide both sides by 5 to get x on its own, and x is going to equal 84. So I've found out what the volume of the fuel tank has to be, and you can substitute that into the original question and find out that yes, x is going to be 84. That's how big the fuel tank, that has to be the volume of the fuel tank. Okay, I'm going to let you try this one on your own using the same principles again. So if you just pause the video and try to do that one. Okay, so you were asked to travel 1/4 of a journey. The next day you travel another 1/3 of the journey. You have traveled 105 miles. How far do you still have to go? Okay, so we traveled 1/4 of the journey. How do you find out a quarter of something? You divide it by 4. So we're letting the distance of the entire journey be x miles. So that total distance divided by 4 is 1/4 of the journey. Okay. The next day you travel 1/3 of the journey. So x miles is the total journey. You've then gone another third of that journey, which is x divided by 3, to find a third of the total journey. Okay. And you've traveled 105 miles. So this is day 1, that's day 2. Day 1 and day 2 added together, you've traveled a total of 105 miles. So again, we need to manipulate these fractions and add them together so we can work out what x is. So x over 4 becomes 3x over 12. X over 3 becomes 4x over 12. We add those together. We get 7x over 12 equals 105. I can multiply both sides by 12. 7x equals 1260. X equals 180. Because I've divided both of these by 7. And if we substitute that in, I travel 1/4 of a journey. 1/4 of that is going to be 45. The next day you travel another third. 1/3 of that's going to be 60. 45 add 60, yes, you've gone 105 miles. How far do you still need to go? 75 miles. So we've used algebraic fractions to solve that problem. Okay, so I'm going to allow you to attempt some of these using the methods we've already used. The first one, the lowest common multiple is just going to be 2a. And that's going to be your answer in the end. So I'll let you attempt those questions. Pause the video and try them, and then I'll come up with the answers. Okay, some of them we didn't actually need to multiply the two denominators together. For example, the first one, the lowest common multiple is going to be 2a. All you needed to do was double the second fraction. For the second one, all you needed to do was triple the first fraction to make it into 9 over 6a. Add them together to make 14 over 6a. Okay, looking at slightly harder ones. If we go back and remember our first question where we were just adding normal fractions, we had a fraction over 7, a fraction over 5. We multiplied them together to get the lowest common denominator of 35. Same principle applies here. We're multiplying these two together, and our new lowest common denominator is going to be a times a plus 1. So we're just multiplying these two together to get a times a plus 1. Convert both fractions so that they have the same denominator. Well, what are we going to do to the 5 over a? Well, how do we get the denominator of a into a denominator of a times a plus 1? We simply multiply the a by a plus 1, and what we do to the bottom, we do to the top. So we're left with 5 times a plus 1 over a times a plus 1. So that's our first conversion. And now we've got the 2a plus 2 over a plus 1. How do we convert that? Well, we look at this a plus 1. How do we change that into a times a plus 1? Well, we're going to multiply both by a, and that's what we get. Yeah, all we've done there is we've multiplied the top and the bottom both by a, because we wanted the lowest common denominator of a times a plus 1. You'll notice again what I've done is I've taken 5 over a and I've multiplied both of those by a plus 1. So I got 5 over a became 5 times a plus 1 over a times a plus 1. And all I've done to these two fractions is I've multiplied them both by a to get this. Okay, now I have the same denominators. The denominator in my answer is going to be the same, and as you can see, I've just taken the 5 over a and multiplied them both by a plus 1. I've just taken this fraction over here, multiplied those both by a, because I wanted these two numbers multiplied together to be my new lowest common denominator. And now I have the same denominator in the answer, just adding these numbers together. Then I can just simplify them. Into that, and then into that, and then into that. Now normally that's where you'd end. If it was a really tricky question that asked you to factorize the answer and put it in its simplest form, which we can actually do in this case, we can factorize that numerator into this, and then the a plus 1's cancel each other out, and we're left with that. Now we can actually check to make sure that we did it correctly. Check to make sure that 5 over a plus 2a plus 2 over a plus 1 does equal this fraction over here, just by substituting. Let's substitute 1 into a. We have 5 over 1, which is 5, plus 2 plus 2 over 2, which is 2. 5 plus 2 equals 7, and in our answer we have 2 plus 5 over 1, which is 7 over 1. So both of those are equal to 7. So in that case we can actually check that we've done it correctly, that this actually makes sense, because we've substituted a to make a 1, a equal 1, and the answer comes out as correct in the end. So you might want to pause the screen and see the similarities between adding normal fractions and adding algebraic fractions. The exact same steps were taken in each one. And here is normal fractions and slightly more difficult algebraic fractions. The exact same steps were taken in each one. So hopefully you found that useful. If you remember how to add normal fractions, that's going to help you to understand how to add algebraic fractions. If there's any steps in the video you don't understand, please make sure you speak to someone who knows what they are talking about. So thank you very much, and I hope you found that helpful. You can attempt this question as well, which has got to do with algebraic fractions, and see how you get on with that.